Hello, my dear students. This is Pati, Pati, Senior Lecturer, Post Kata, and today we are going to discuss about the analogy electronic circuits and especially the transistor, how it is operating, and how the different parts is functioning, what is the current flowing, and how it is doing the amplification part by taking the input signal and giving the output. Let us start the details. The watt transistor, the watt transistor. Actually, if you break this particular watt into two parts, one is a trans, another is star. This trans stands for transformation of resistor. What does it mean? This transformation of resistor, it clearly indicates that the resistance part, when we are giving the input and taking the output across this input and output part of the transistor, the resistance parts gets transferred from low to high. That means if it is a transistor, then its input resistance is low and output resistance is high. That is why when the output at the output side, when the current flows, suppose let's say I, because of this resistance part, so your voltage drop becomes high as per the rule V equal to I. So whatever input signal you are giving, it will be simply increasing, or we can say it is getting amplified. So like this, we can discuss about the part of the transistor function, everything in detail. So let us consider about the part of the transistor. Actually, before going to the transistor part, let me discuss something about the diode. As you know, when a p-type semiconductor is suitably charged with a n-type semiconductor, so there is a formation of p-n junction. This is your p-n junction. This is what is junction, and it has got two terminal 1 and 2. This particular p-n junction, we can sectionally also visualize this. Okay, so this is p, this is n. So like this, we can draw the component diagram like this. You see, this particular part is called P and the bar part is called N. So this takes positive sign, this takes negative signs. That is why this side is plus, this side is minus. So why it is I am telling? Because the concept of diode is actually emerged into the concept of transistor. So this particular diode, we are having two types of connection. One is the forward bias and another is the reverse bias. So if you connect it, suppose if I connect like this is your P side and this is your N side. P is connected to positive terminal, N is connected to negative terminal. Then this particular connection is called forward bias connection. And similarly, if I connect P and N, P to negative side and N to positive side, then this type of connection is called reverse bias connection. Accordingly, I can also connect the diode diagram. If I take actual real diode here, this is positive, this is negative. So if I connect it to positive and this is to negative, this is your forward bias connection. And similarly, if I take a diode and connect it to negative terminal, then it is positive terminal to negative, your anode side, then this is plus, this is minus, this is becoming reverse. So why I am discussing? Because if a transistor, particularly if I take a transistor, the transistor is having two types of NPN transistor, another is PNP transistor, right? What does it mean? This systematically we will understand one by one. Suppose I am taking NPN transistor, okay? Now, this NPN transistor, actually, if I draw this sectional diagram, this is your NPN transistor, this is your N side, this is your P side, this is your N. So this is your NPN transistor. If I make it a sectional view, it will be looking like almost like this. Okay. Now this is your N, this is your P, this is your N. So if I make a little editing like this, you see this particular part is have been divided into two parts. One is P, another P. That means it is a half P. This is a half P. And here is your terminal is coming out. One terminal, two terminal, and three terminal. The first terminal is called emitter. This is your emitter. And the second terminal is called base. And the third terminal is called your collector terminal. The component diagram, if I draw, the component diagram will be looking like this. You see, it is looking like this. This arrowhead particularly indicating external outwards. So it stands for NPN transistor. Here it is your base terminal, here it is your collector terminal, here it is your emitter terminal. There is a concept, the particular diode is extending towards external part. So it indicates that current is coming out. This is your emitter current. So definitely the rest of the two terminals or the rest of the two parts in which currents are coming in. So one current is coming through this side, one current is coming through this side, and after getting into the transistor, both are going outside. So this is incoming current, base current IB, this is incoming current, collector current IC, and the net current one is going out, that is your emitter current. So as per the Kirchhoff's current law or KCL, the algebraic sum of the currents meeting in a point in a closed loop or mesh is bound to be 0. So like this, if I write the incoming current as positive and outgoing current as negative, so I can write like this. This is your minus IB and this is your minus IC and this is your outgoing positive, so only IE. What does it mean? The incoming currents, sum of the incoming currents like this, and the outgoing current is IE, only positive. So sum of all the currents meeting at a point is 0. So if I segregate all this, I will find IE is equal to this minus sign, this minus sign. If we go to outside, it will be positive automatically. IB plus IC. So the emitter current is equal to base current plus collector current. So like this, if we go to the PNP transistor, so it will be like this. One is PNP. Here is three terminals. One is emitter, another is base, another is current. So what does it mean? The component diagram of this PNP transistor is like this, but there is a difference. What is the difference? You see, in case of NPN transistor, the arrow is heading outward. Here, the arrow will be heading towards inward. That means here the current was going out, but here the current, as per the arrowhead, it is going in. So it will be going in, no doubt. It is emitter part, so IE. Obviously, the incoming current, whatever is coming here, it has two paths to go out. One is through base, another through collector. So this is base, and this is your collector part. So two parts are going out. One is base part, that is IB, base current. Another is collector part, that are IC or collector part. So accordingly, putting the same algebraic sum of the current meeting at a point in a closed loop or base as per the Kirchhoff's current law, we can draw. Here see, we are taking incoming current as negative and outgoing current positive. We will take the same fashion there. Incoming current as negative, that means minus IE plus all outgoing currents. It is see, outgoing current was positive, so I will take all positive. That is your outgoing current IP and outgoing current IC, that is equal to 0. Now, segregating all this, I can well get the current equation. If I take this IE to that side, final equation it will be IE is equal to IB plus IC. That means out of this equation number 1 and equation number 2, we found that maybe NPN or maybe PNP, the current equation stands same for both categories. Now, question arises. Actually, what is the role of diode inside the transistor? See, in case of a diode, there are two semiconductors. One is P, another is N. P type semiconductor and N type semiconductor. But in a transistor, of course, it covers three layers, NPN. But in two layers, another two layers has been overlapped. How it is overlapping? You see, the one part of NP, it is like this, this is one part, and similarly, this is another part. That means this is a NP, this is also NP. That means one NP or PN forms a diode. So here, one pair of diodes, that means two diodes have been connected back to back. So when two diodes, basically two PN junction diodes, when connected back to back, keeping P as their common, so there is a formation of P type transistor, NPN transistor. How? It is a NP, it is also NP. Two diodes have been connected back to back, keeping their P as common. So there is a formation of NPN transistor. Similarly, if we draw this, it will be like this. This is your P, this is your N, this is your N, this is your P. So this is one diode and this is another diode. Now, same concept. When two PN junctions diodes have been connected back to back with each other, keeping N as their common, then there is a formation of PNP transistor. Now, looking to the same diode component diagram, if we draw this, you see this particular, just look to this part. This is P is this part. This is N is this part. That means the bar part is N and the arrow part is P. If I put it here, particularly in NPN transistor, you see this is N, this is P. My P is arrow part and N is bar part. So how it will be looking like? This particular part for this NP, it will be like this. See, N part is bar part, P part is this arrow. This is N, this is P. Now, similarly for this, the component diagram, how it is connected? It will be connected like this. See, this is N part, and this is P. Now, this side N, that side N, the internal middle point part, which is sharing with each other, this particular P with P. This is a half P, this is a half P. So, in this particular diagram, whatever common component diagram we are drawing here, if I resemble it to the inclusion of two diodes, how it will look like? See, one is heading to this side, another is heading to this side. So So my component diagram will be like this. Look at here. This particular thing is shown to you in horizontal. If I make it vertical, so one diode will be external to that side and another diode will be external to this side. So it will be like this. Okay. Now this is your P part, this is your N part, this is your P part, this is your N part, and this is your as usual base, collector and emitter. Now the half of P of one diode, half of P of another diode, taking together, the base has been constructed as a total P, and this part is N and this part is N. Similarly, if we take this concept to that side also, we can draw the actual inclusion of diode inside the transistor. It is looking like this. Okay. Now see. This is my P, this is my N. So how it will be like this? My P is C. Once again, my P is this. So if I take this, N is bar. So my diagram will be like this. This part is P, this is my N. And here also the same situation. Okay. Now this is my P, this is my N. Now taking this N, half of N, the total common N is like this, and this P to this side, this P to this side. So if we just reflect the same concept in our component part, how it will look like? It will look like, see, it was heading towards outside. Here both the diodes will be heading towards inside. So it will be like this. It will be like this. Plus, minus, minus, plus. This is your, this particular part is your N, this particular part is your P, this particular part is your N, and this particular part is your P. So taking half of N of one diode, half of N of another diode, this particular part is total N, this is total P, this is total P. So as you know, this is your collector, this is your base, and this is your emitter. So finally we are getting a PNP transistor. So my point of view is that though it is a transistor, actually a transistor consists of two diodes, and depending upon the fashion of connection of these two diodes, there are formation of two transistors NPN and PNP. So basically, if we convert our definition into another part, we are having a definition like this. It is a three terminal. You see emitter, collector, base. The transistor is a three terminal, three layer, and two junction. This is your junction 1 and this is your junction 2. Similarly here junction 1, junction 2. Okay. So we can draw a definition about the transistor. Transistor is a tri-terminal, tri-layer, bi-junction semiconductor switching device. Let me repeat it once again. It is a tri-terminal, tri-layer, bi-junction semiconductor switching device. What is this switching? It is switching from low resistance to high resistance. So anyway, this is the connection diagram of this transistor. Now we shall discuss about its working, how the junction 1 and junction 2, one is forward biased, another is reverse biased. Forward biased is providing low resistance and reverse bias is providing high resistance, for which the transformation resistance situation occurs, so that a signal jumps from input to output with a high voltage, and the voltage drop across the output through the low resistance RL becomes high, so that transistor becoming used as a amplifier. Okay. So now if I switch over to that, let me discuss any one of the fashion, maybe NPN, maybe PNP. So see, this is my let me draw a NPN transistor. Suppose this is your your N, this is your P, this is your N. Okay. Now here it is your N side. In case of N side, I have already told you in my last class. Let me just make you remember. In N type material, the majority charge carrier is electrons, and minority charge carriers are holes, right? And in case of p-type material particularly, this is becoming crisscross, like electrons comes to minority side and holes come to majority side. That means majority, this is your n-type material, this is your p-type material. In p-type, the majority charge carriers are holes and the minority charge carriers are electrons. So let us come to the block diagram here. This is n-type material. Obviously, the majority charge carriers are playing the vital role. So I will consider the majority charge carriers. For the timing, I am not considering about the minority charge carriers for your sake of simplicity for understanding point of view. So I am taking only the majority charge carriers. The majority charge carriers are electrons. Let's say here are the electrons like this. 9 number of electrons. All are majority charge carriers. Okay. Now, in case of P, the majority charge carriers are, I am considering only the whole part. This electrons means all are negatively charged, holes means all are positively charged. So these all are electrons, these all are holes. Similarly, in N side, this negative electrons all are, right? Now, what is happening? I need to have a forward biasing for the input side and reverse biasing for the output side. So as I have already discussed, I will make it forward biasing. How? Now N is connected to negative terminal and P is connected to positive terminal. Similarly, for making it reverse bias, I need to connect P to negative and N to positive. Right? This is your emitter part, this is your base part, this is your collector part. So, see, this is the current, negative to positive, it is flowing in this direction, negative to positive, it is flowing in this direction. Whatever it is coming current, it is getting divided into two parts. This is your emitter current IE. This is one part is going inside. This is IB. Another part is IC. So the same equation it is following. Incoming current is equal to the sum of the outgoing current. IE is equal to incoming is equal to the outgoing current. Sum of the outgoing current IB plus IC. So this particular voltage is in between base and emitter, so it is called base emitter voltage VBE, and this is between base and collector, so it is called VCB. Because in our transistor, this is emitter, this is base, this is collector. A reverse notation, particularly, it is operated. You see BE, B to E, and C to B. It is being followed here. Okay. It is not, it is clockwise. It will move emitter to collector, collector to base, base to emitter. So VBE, VCB, this type of notation is being used. Okay. Now what is happening? This is the concept of battery. Before jumping into that, let me discuss about the battery position. Suppose, just consider, here is a bucket of water is there, inside which there is a valve, and inside at the bottom head there is a stopper, and both the part is filled with water. Suppose here it is also filled like this. Now what will happen? If we just open this now, obviously the water will start flowing from this side to this side, that side, because the water in the left side is in higher concentration and the water in the right side is lower concentration. So obviously by the law of nature, this situation arises, water starts from flowing from higher concentration to lower concentration. How it is flowing? And up to what extent it will be flowing? It will be flowing till both the sides have been labeled 1. So that means this amount of excess water it will be filling to this side. That means all the water will move to this side. Obviously, after moving of this water particle to this side, this will be backhand. That means the backhand space came to this side. So if I consider this particular water particles are electrons, suppose this is electrons, and this backhand part, white or backhand open space, whatever I am telling, backhand part, suppose it is called holes. What does it indicate? When the electrons move to this side, holes move to its place of electron. Because water moves to a backhand space move to the position of the water. Similarly, when electron moves to the whole part, hole moves to the electron. It is an automatic process. Now, how it is flowing? From higher level to lower level. Here is the same situation. When I am putting here like this, it is higher concentration of electron, this is lower concentration of electron. This higher concentration of electron, when it moves from this side to this side, automatically electron moves to this side, means hole moves to this side. Okay? Now see, if I suppose one electron is moving to this side and on the contrary holes are moving to that side, this electron is coming here and getting deposited here. Similarly, you just see what is happening. This hole is going to this side and again it is coming here and getting deposited here. What is happening? After a couple of seconds, suppose this side is becoming 12 electrons. Now these 12 electrons will attract these 9 electrons or repel this 9 electrons. Obviously, this 12 electron will repel these 9 electrons towards the junction. This is your junction number 1 and this is your junction number 2. This is input junction, that is output junction. Now, this 12 number of electrons will repel this 9 electrons towards the junction, and this particularly suppose 12 hole, it will repel this 6 number of holes towards the junction. So obviously, if I draw a picture, now all the electrons will be accumulated near the junction and the holes will be accumulated near the junction. That means the junction is now pressurized by both the charged particles from both the sides. So it will go on losing its resistance one after another period of time. On the contrary, what is happening in the negative part or junction 2 part? What is happening? See, the electrons from this side to this side it is jumping, and on the contrary, the holes are coming to this side. Now holes are getting deposited here, the electrons are going to this side. Okay. Now this hole, particularly suppose 12 hole, this will attract this 9 electrons towards this side, and at the same time this 12 number of electrons, it will also attract this 6 number of electrons from the junction. So here what is happening? The 9 number of electrons will be away from the junction, and these holes also will be pulled from the junction, so that there is a gap increases near the junction. It indicates that the junction width is becoming more or thick. What is happening here? The junction width is becoming less or thin. So which one is thin? It offers low resistance, and which one is more? It offers high resistance. Okay. So after some time, this junction due to low resistance is go on breaking, so that what is happening? Both the charged particles diffuse into each other side, so that input side starts conducting, and on the other hand, the output side is offering high resistance. The mode of operation is almost the same for NPN and PNP. Here we are taking magnetic charge carrier, electron, hole and electron. There we will take the magnetic charge carrier, hole, electron and hole. Only thing, the magnetic position will be reversed, that's it. And if we draw the VI characteristics, volt ampere characteristic, voltage is taken in x-axis and current in y-axis. So the input, it will be like this. Sorry, it's not like this. It's not like this. So like this, you can get a graph like this, and finally this is all about your transistor part, how the transistor works, and how NPN and PNP are working depending upon the diode position and connection diagram, and finally transistor is used as an amplifier. So that's all about this chapter today.